This is AQA Statistics, Continuous Random Variables 5. This video is about deriving formulae for the mean and variance of the exponential distribution. Please pause for a moment to remind yourself of the formula for expectation value. The limits won't necessarily be negative infinity and positive infinity, depending upon what function you have for the PDF. The expectation value, remember, can also be described as the mean value. Okay. The formula for the mean of the exponential distribution is 1 over lambda, where lambda is the parameter of the distribution. Here's the PDF, and we can see that the PDF is 0 when t is less than 0. What we need to do then to find the expected value of the random variable is to integrate t from 0 to infinity, and what we need then is we need to multiply f of t by t. So what we're looking at here is t f of t. I'll just put the constant in front of the integration there. This integration will need to be done by parts, and the two parts will be lambda t will be the element that we wish to differentiate, and e to the minus lambda t will be the one that we are going to integrate. Pause the video and make the first step of the integration. Here is the first step then. So the integration in two elements here. So the first step is that we've integrated e to the minus lambda t, and that appears in both cases here and over here. And the one that we've differentiated is lambda t. So in the first bracket we've got lambda t, and over here we just have lambda. Please pause the video to simplify the bracket at the left side here, and also to simplify the integration. What you should have found is that this first bracket simplifies to 0. When t tends to infinity, then this term here, e to the minus lambda t, will tend to 0. And when t is 0, then lambda t will be 0. So this whole thing actually becomes 0. And the integral simplifies as follows. Please pause to do the integration. This is what it looks like. So here is our integral, and then we need to substitute the limits. First of all, e to the minus infinity. Now we know that's going to tend to 0. So that one there becomes 0. And e to the 0, of course, is 1. So there we are. We've got the formula that we require, 1 over lambda. Please pause to remind yourself of the formula for the variance of a continuous random variable. The formula consists of two components. Here we have the expected value of x squared, and down below here we see the formula for deriving that. What we need to do is to integrate x squared fx, where fx, of course, is the PDF. Having found the value of the expected value of x squared, we then need to subtract the square of the expected value of x. We'll begin the derivation by finding the expected value of t squared, integrating using the same limits as we used to derive the mean from 0 to infinity. But what we're now doing is we are integrating t squared f of t dt. And this again will need to be done by parts, and the two parts are going to be lambda t squared and e to the minus lambda t. Please pause the video to complete the first step of the integration. Please pause to simplify this square bracket here, and also to simplify the integration. Hopefully you found that this first square bracket simplified to 0, and then the integration here simplifies as shown, and we're now left with this rather simpler integration to do. If we take a look at this integral that we require to find the expected value of t squared, what we can notice is that the shape of it is very similar to the integral that we already did to find the expected value of t, and in fact that the expected value of t squared will be a simple multiple of the expected value of t. So if we consider the expression we've got here for the expected value of t squared, taking t outside the bracket and then placing a lambda in the denominator of this fraction outside, we'll obviously need to put an extra lambda inside. What we can now see is that we have the 2 over lambda times the expected value of t. Expected value of t, remember, was 1 over lambda. So we finish up with a formula for the expected value of t squared, which is 2 over lambda squared. Remember, this is not the variance. This is the first element that we are going to substitute in the equation or the formula for the variance. Here's the formula that we derived for the expected value of t squared. Finally, we need to substitute into the formula for the variance. So looking at this then, we can put in 2 over lambda squared for the expected value of t squared, and then of course the expected value of t was 1 over lambda. So what we're finishing up with here is 2 over lambda squared minus 1 over lambda squared, and that is 1 over lambda squared, the formula for the variance of the exponential distribution. The standard deviation of the exponential distribution is derived from the variance here, so here we see our formula for the variance. The standard deviation is simply the positive square root, so here's our formula, 1 over lambda. That completes the videos on the exponential distribution.